Srinivas to present his talk on solving problems in the modern science using Bhagavad Sankhya. We welcome you, sir.
So this is the title of my presentation, Solving Problems in Modern Science using Principles of Bhagavata Sankhya. So Bhagavata, I mean the Bhagavatam. So this is the abstract of my presentation. So quantum mechanics, as we know, the very modern innovation and for the past 100 years is driving forward the technologies. So it allows us two or more particles to exist in an entangled state. Once we see everything, we are able to perceive in this world because they are entangled. They have some connection. Just like you have a clock, there are strings running across, and that's why the clock is in place. So then there was Schrodinger, the year 1925. He was proposed a theory by which he could bring together two contradictory aspects of nature, whether light is a particle or light is a wave. Then he combined this with the equation that they are one kind of an entanglement. So another important topic is causality. We want to analyze this world in terms of cause and effect. We see something, we try to analyze the cause. And we are observing something and we want to foresee what could be the cause. The Srimad Bhagavatam is all comprehensive knowledge. So there, the very important statement here is that all subtle material elements are actually present within the gross object. And the gross elements are present within the subtle cause. So just like we see that from ether, comes air, and from air comes fire, fire to water, and water to earth. So each progressively we see the qualities manifest. For example, either there's only sound element, then it comes to air, there's a touch element, fire, there's form, then water, there's taste, and earth, there's smell. But actually, what we perceive as this earth, water, fire, and these are also gross, and they have a subtle form also. So because how can a quality which is not existing in the cause manifest in the effect? For example, earth has 5 qualities, and how can we say earth came from ether, which had only 1 quality? So which means the subtle form of earth, water, fire, air, and ether, when they combine, they gradually become gross form of ether, air, fire, water, and earth. So can we adopt our philosophy to solve the unsolved problems in modern science? So that is the theme of this presentation. So let me look at some of the inspirational quotes. It's a very important chapter of the Bhagavad Gita. Where it says, the Sankhya Yogam Pritapala Pravidhanti na Panditaha Ekam Astita Samyak Bhubayor Vindate Phalam. Only the ignorant speak of devotional service, Karma Yoga, as being different from the analytical study of matter and Sankhya. So someone may think if you are a spiritualist, you are referring to scriptures. Maybe you cannot describe modern science. What is the other statement? Those who are actually learned say that he who applies himself well to one of these paths achieves the results of both. In other words, whether you want to be scientific or you want to study the scriptures, the conclusion should be the same. So religion and philosophy have to go hand in hand. Yet Sankhya prapyate anam tat yoge api gamyate ekam sankyam cha yogam cha yat pashyati sa pashyati. One who knows that the position reached by means of analytical study. So analytical study means we want to be rational, we want to study this word, can also be attained by devotional service, by studying the scriptures, following the saints, and who therefore sees analytical study and devotional service to be on the same level, sees things as they are. If you want to have real complete knowledge, then you have to depend both on analytical as well as the scriptures. So someone can keep track of the time also because this is a very important verse which I was earlier referring to, which I drew inspiration from this particular verse, 11th canto, 22nd chapter, 8th verse, in Sankhya Yoga, where Krishna is instructing Uddhava before he leaves this planet. He gives much broader than the Bhagavad Gita. Ekasmin avi drishyante pravishtami antarani cha purvasmin va parasmin va tatve tatvani sarvasha. All subtle material elements are actually present within their gross effects. Similarly, all gross elements are present within their subtle cause. So we have something gross means which I can perceive. I can hear, I can smell, I can taste and touch, I can see. And subtle means as its material creation takes place by progressive manifestation of elements. So it is from the subtle to the gross. But unless there is something in the subtle, it cannot manifest. So just like the pandemic, we are a big confusion. We were not able to trace out the causes or what will be the consequences. And those who can find all material elements within any single element. So that's what I was saying. From ether itself is having those qualities, but it doesn't manifest unless it is transformed into earth. So this very important philosophy known as Achintya Veda Tattva was promulgated by Sri Chaitanya Mahaprabhu. So basically, this is about what is the relationship with God. Are we one or different or simultaneously one and different or inconceivably one and different? So there are many philosophies, but this philosophy can also be applied to the material elements because the material energy is actually the energy of the Lord and it also has inconceivable properties. Just like we say, an electron is both a particle and a wave, but how can it be simultaneously a particle and a wave? So that is also due to the Achintya Shakti, and Achintya means inconceivable but true. Okay, these are as far as the inspirational quotations. Now some background and references in the modern context. So this was my papers which inspired me. List of papers by Dr. Ravi Gomatam, and he has done very pioneering work. I got introduced to him about 30 years ago when I was in IIT Bombay, and I've been thinking about this topic very deeply during the pandemic. Of course, we lost many valuable things, and it was a big blow, but it was a good opportunity to move forward in life. So these are some useful videos on big data analysis. Why physicists are not able to understand quantum mechanics, although they are used, all the technologies are derived based on this quantum mechanics. Still, the interpretation is daunting. And I'm going to introduce about imaginary numbers. Imaginary numbers have been existing for nearly 2,000 years. They have been in between the people dismissed it, saying that it has no physical significance. But again, it came into prominence about 500 years ago. And particularly 100 years ago, Schrodinger was able to propel this field of quantum mechanics because he used this concept of imaginary numbers. So there's some more video about how the equation was involved and what is the current level of debate in quantum mechanics and where is it going. So let us look at René Descartes. He was a 16th century mathematician, philosopher, scientist, and he proposed this theory of re extensa and re cogitans. So whatever we observe, supposing I hear some sound, it has a range of frequencies. Similarly, I see something, it's a range of colors. Or I smell something, it's a range of odors. Or I see something, again, temperature, we touch something, touch is based on the temperature, that is also a range. And we hear, that's also a range. So like this, it's known as extended substance. Whatever we observe in this world, is having an extended presence. Supposing I ask what is the exact position of the state, if you are a mathematician, you will try to say what is the center of gravity x, y, z. But we know it is extended. You cannot exactly say it is at this point. It is spread out. Then we have what is known as res cogitans, unextended thinking substance. Can anyone point and tell where is our mind? So all the objects we perceive, all the experiences we have in this world is not possible unless we have a mind or a conscious person. But where is the mind? Can anyone locate? Although we say it is maybe brain, but can we exactly pinpointedly say where the mind is? No, because some animals they do not have even a brain in terms of the physical brain. So his why this philosophy was proposed is at that time, if you deviated from the Christian scriptures, you were condemned to death if you spoke anything against the scripture. And so he was trying to instigate this that yes, scriptures are talking about something which you cannot experience. So why do you depend on scripture? And if you say, no, I will try to understand the world and develop my knowledge, then also it's very subjective. For example, if I ask anyone, all of you, to describe what you're observing here, you are sure that, of course, there may be some common points that definitely each of you will come with some differences. So this means that knowledge acquired through our direct perception is subjective. So then how to make it objective? So similarly, it's possible that if you are studying scripture, each one will understand the scripture differently and it will become subjective and therefore there can be a division. One person will go one way, another person one way and argue and this will go on ever. So how to make it objective? So there's something called quantum mechanics has very two important concepts of superposition and entanglement. So what is superposition? Supposing if I want to describe this object, first I have to explain how it looks. Maybe the color is black. Or I can say it weighs some maybe 100 grams. This is the weight. Or I can smell it and say, for this flower is there, I smell it and say this fragrance is like this. Or I describe it in terms of the sound it makes. Or like this, there are 5 perceptions we have. I can describe this quality. But how can a machine recognize this? Like, try to measure these 5 properties. As a human being, immediately I can judge. If I see an apple, I know what its taste is, what its color is, what its smell is, what could be its weight. And all this human being, I can perceive immediately. But if I want a machine to recognize these properties, it can do only one at a time. I can have one machine for detecting the weight, one measure for detecting the color, one measure for detecting the odor. But I cannot devise a machine which can simultaneously measure all these properties at once. But this is the concept of superposition, where if you make a measurement about this, you would only observe one property at a time, but not. Or another example is there of the elephant. 5 blind men were trying to understand an elephant. Each one perceived differently. They touched the tail, one touched the leg, and one the belly, and the ear and trunk. So they came to. But then, how do you combine this information? And that is the concept of superposition. Entanglement. Entanglement, as I said, supposing you have a husband and wife, and you're trying to predict their behavior. So once you know how they behave with each other, it's very easy to predict. Okay, the husband is like this, so the wife must be doing like this. So similarly, material nature also has this property where things are connected. So if you carefully look into material nature, you can see the connection and you can predict the behavior, even though it is far, far away. Because in our scriptures, we are talking about what is happening across the universe. So how can we believe that? So scientists also now coming to the conclusion that quantum mechanics is proving that even things which are far, far apart, if they are entangled, they have a connection already existing, then we can predict. This is a Schrodinger equation. What is the greatest contribution of Schrodinger is that previously they were trying to understand whether light is a particle or a wave. And they had some experiments to prove exactly that yes, light is a particle. And some experiments to say that light is a wave. So this is like simultaneous one and different. But then they came up with the experiments like the Young's double slit experiment, which showed that must be simultaneously wave and particle. But then there's a problem with how to interpret this. So he developed this equation, which particularly, if you notice carefully, there is this imaginary number I. I'll come to explain why this imaginary number is very important, because he's trying to correlate 2 things. One is the left-hand side of this equation is talking about the wave nature. For example, h into the angular momentum is giving the energy due to the, you assume it is a wave, then its energy is given by h into frequency. And if you assume it's a particle, then you have to use the right-hand side of the equation, which is saying that it has kinetic energy, it has a potential energy. So these are 2 forms of energy. So to combine them, then he had to use this imaginary number. Because earlier they used to have wave equations, but they were non-linear. So, but he wanted to linearize it, and that was possible only because he used this imaginary number. So what happened was, when the Schrodinger equation was developed, as I said, he had this imaginary number sitting here, which is square root of -1. But he was not happy because he could not give a physical significance. Any number is there, I say 10 or 12 or 0.1 or 0.2, I can measure it, I can devise an instrument to measure it. But how can I devise an instrument to measure imaginary numbers? So then one suggestion was, maybe you can multiply this complex number by a complex conjugate and get a real number. But of course, it solved the problem, and all the modern technologies based on quantum mechanics are based on this conversion of that complex number into a real number. But it led to loss of problem of interpretation, because the complex number has a physical significance. You can understand, just as I said, 2 complementary things. I come to that again. How we analyze in a complex way. We think we are realists, but actually we understand things in a complex way. So this was the main drawback in the sense in this approach, that they tried to convert a complex number into a real number, and this way they lost valuable information. So a lot of debate was going on, although a lot of technologies are being introduced and it was going much ahead, the philosophy was going behind. It was not able to match up with the technology. And people thought, doesn't matter, we don't need to know how it works, as long as it works. Nobody knows how the mobile phone is working, but as long as I can use it, and very good. Nobody knows how the vehicles are moving, but we use the vehicles. So there was some opposition, or there possible interpretations to the equation, his own equation. He came up like many words interpretation. Then Schrodinger came up with this problem was known as the measurement problem. Because at the subatomic scale, you are observing phenomena which makes it appear as a wave sometimes, as particle sometimes. But in real life, we don't see things like that. We see only particles. We don't see waves move. Although we are using all these devices because of the waves. But I don't see waves in front of me. I see a person sitting here, an object here. I don't see a wave. But when you say atomic side, you are seeing it as both wave particles. So how do we reconcile this? So that's what he termed as a cat paradox. Cat means I can visibly see a cat and say it's either there than another, but I can never say it is simultaneously there than another. But an subatomic particle, we are saying it is simultaneously in one place and not in one place. So this was the Bohr-Einstein debate that Einstein argued that this quantum mechanics which you have proposed is incomplete for two reasons. One is the mathematics is incomplete and the interpretation also is not sound, because any mathematical theory you have, you should be able to explain it with the physics. It should have, you can, I have to demonstrate it. But then Bohr said, no, it is like that. You have to use complementary things. Just like if you want to like you accept the wave and your particle, sometimes you accept it as a wave, sometimes a particle, and don't question beyond that. It's the problem with the language. So that's where it ended. Now, Einstein is two students, Podolsky and Rosen, they brought up this argument against basically the quantum mechanics people are saying that it's all probabilistic. All things are happening by chance. And that's how we have to use probability and predict things. Supposing if I ask you whether it will rain or shine, you will try to only predict. Nobody can accurate. Of course, they are quite accurate, but still, you think they see that things are probabilistic in nature. So he questioned this, that maybe there is some binding law in material nature, which we don't see it, but it must be there. If it's not there, definitely it cannot happen. Although, just because I do not know what is the underlying binding laws, doesn't mean there is no law. So he gave some thought experiments, and that's what this paradox is about. But then, in the next, they try to find out whether this is really true, whether the nature we are observing is a chance event, everything is happening by chance, something which can predict it, something cannot predict, or everything is well defined. In other words, Einstein said, does God play dice? Which means, do you think God is playing dice and chance, everything is happening by chance? No. So they developed some mathematical equations and some experiments to verify this. So that was the basis for the Nobel Prize, which is awarded recently in 2022 for physics. Three people, Alan Aspect, John Prosser, and Anton Zeilinger. They tried to show by experiments and logic that things are happening by chance and not by, cannot have a hidden variables or then there is nothing mathematical. So just have a quick look at this formula. So here you see they have some, they're actually defining the probability of occurrence of some events. And the sum of the parts should be greater than the sum of the whole. Anyway, here is they are assuming all real numbers. As I said, whenever I measure something, I express it in terms of real numbers. Nobody measures anything in terms of complex number. So when you use real numbers, it will neatly fit into this equation. And whatever experiments are based on the understanding that the events are based on real numbers, will either you can say it violates or doesn't violate. So they came to the conclusion that this equation is violated, and therefore things are happening by chance, and that's what quantum mechanics is. So this is the Nobel Prize. So experiments are successful, that doesn't mean you need a theory. That is the highlight. But then Lord Kelvin was there 100 years ago. He said that unless you are able to express something in terms of numbers, supposing I say you made a profit or a loss, unless I show it in terms of figures, some numbers, my explanation is not complete. So this was the, before even the Schrodinger equation of quantum mechanics could develop, he said that anything you explain physically, you have to justify it with some mathematics. So this recent paper in 2015, a person has analyzed what are the 10 biggest unsolved problems in physics. He said there are many more, but then he focused on 10 important problems. So then what is the conclusion he has reached? So he's saying that here is very important. My own private crystal ball tells me that several of the great mysteries are not independent. In other words, there may be so many mysteries, we may say, but ultimately they are all related. they could be and must be solved simultaneously. It means there is a universal theory. Even scientists are looking for a universal theory. Can we have a theory which explains everything? So how can we explain? He says that the solution is spelled non-linearity. In a linear theory, the whole is exactly equal to the sum of the parts. You have mass balance, energy balance, momentum balance. So what you're trying to do, your parts should be equal to the whole. But then he says, all in non-linear theory, the whole is more or less than the sum of the parts. It need not be. The reality is that need not be that mass is conserved, energy is conserved, moment is conserved. Okay. So all classical theories are independently non-linear. All this friction, gravity, turbulence, whatever equations you have, mostly they are non-linear in nature, while quantum physics is exactly linear. So when Schrodinger developed his equation, he wanted to have a linear equation so that he can add those equations and produce a solution. Okay. So the probability therefore exists that the answers to some or all of the riddles will be obtained from a future universal theory for the transition between linear and non-linear. So I will explain this a little bit further. So here there is known as the quantum classical dichotomy. Classical is what the way we describe the world and the experienced world, and quantum is how we describe the subatomic. So now there is a disparity between these two because of this nonlinear behavior. So what are the solution path is? Can we, right now we have either linear, nonlinear is simply a quadratic, cubic equation, quartic equation. These are all, as you raise the power of the polynomial, it becomes nonlinear. But then what do you do? If you have a nonlinear equation, you try to linearize. In the process, you are losing valuable information. Just like Schrodinger equation, they try to convert into the complex number to real number. In that way, they lost the interpretation. Now we have a problem with dealing with dimensions. Right now we have 1 dimension, 2 dimension, 3 dimension, but in the scriptures like the Bhagavata and all, you are talking about multiple dimensions. For example, people question when we say Ramayana that Hanuman jumped 100 yojanas and 100 into 8 miles comes to 800 miles. But then we don't see that is the difference. That's not the distance between Lanka and India. So then like this, we say that the Shastras say that the moon is much farther than the sun. But common sense experience is totally different. So do you accept that version of the scripture or no? So this means that Shastras is talking about higher dimensions, and people used to travel from one place to another in the universe in shortest time, which means they were not traveling in 3 dimensions. So can we explain all this using complex and particularly meta-complex numbers? So that is the challenge we are taking up next. So how much time do you have? How much I have got?
10 minutes.
Okay. Yeah, let me plunge into the main part. Now, suppose someone sees this 3 letters C, A, and T. Supposing a child has never learned the alphabets. So for him, it is a design. He's drawing. He's seen some drawing. You can see this shape, and this. For him, it's just drawing. Or a person doesn't know English, it is just some design in black and white. And what about a student who's in the kindergarten? He will start reading it C, A, and T, but he cannot join those 3 letters and say it is a cat. Going further, a person can say it is a cat. But then if you ask a student who's preparing for his entrance exam, he will say it is common admission test. Or a person in the computer field, he will say it as computer aided technology. So like that, the experience is the same. All of the people who came to this conclusion, all of them are only seeing C, A, and T. But when they see, they are using their imagination. All of us right now, when I am talking also, each of you are having your own private imagination. You're trying to understand it in your own way. So this imagination always there when you are perceiving objects in this world. So then how do we come together? So let us say none of the people in the audience are talking about it. So then we all go out of this conference, then we come to different conclusions. But then how to bring together when we start expressing it in terms of language? Right now I'm speaking in English language where you could probably understand at least something about what I'm saying. So language and imagination both helps us to interpret something. So that's what I said over here. So can we say that, first of all, I told there's a superposition and there's an entanglement, which means 2 things are always related. So can I represent that relationship using this A1 and B1? Just like I see a man and woman sitting each other, either I can say they are not related, or I could say they are husband and wife, father and daughter, boyfriend, girlfriend, Also like this, although my experience is the same, but the conclusion can be different. So can we say that, yes, I observed the boy and he has these qualities, and I observed the girl and these are the qualities, and they could have many types of relationships. So this can apply to all the objects around us, just like I say, different people can combine these three letters and come to different interpretations. So should we represent all this using a complex number to better represent the reality? Next. So this is another interesting example given for artificial intelligence. How do I make a machine understand human language? There's an example given here. The statement is like this: I saw the man on the hill with a telescope. This is the statement. But then this can be interpreted in 5 different ways. So there are always 5 interpretations are given. Either the person is holding the telescope and is on the land, and on the hill the man is there, or the person is using the telescope is on the hill and the man is on the ground. So like this, there are 5 different possibilities. Coming back to the earlier example, supposing we have a passage or a book is there in which the word cat comes 100 times. But how do I know this in these 100 times, which one was I referring to? Was I referring to the animal cat? Was I referring to the computer technology? Was I referring to common admission test? So if you say the probability of the occurrence of the word cat is 0.1, that is misleading, because in those 100 times out of 1,000, maybe sometimes I use the word cat to mean the animal, sometimes I use to refer to an admission test, or sometimes I use it to refer to the computer technology. So then the problem multiplies further. Supposing I have this sentence, maybe in one paragraph I'm talking about the man, in one paragraph I'm talking about the hill, and one paragraph I'm talking about my focus is on the telescope. Like, or maybe I'm not even talking about any of these things. For example, in my talk, I'm not talking about the hill or the man or the telescope. I'm just using it as an example. So if I say there's another book in which this sentence comes 100 times. So if you use normal probabilities, the ratio, you express it as a ratio. If I say out of 1,000 sentences, 100 sentences are repeating like this, and I say the probability of this sentence repeating again is maybe 100 by 1,000 is 0.1. But then you have to go into deeper and say that, yes, I use this sentence 100 times out of 1,000, but in each of the 100 times, maybe sometimes I refer to this one, this one, this one, this one, this one. So how do I refer that? So unless you use complex numbers for representing probability, you are going to go off track. And that is what the current problems we are facing. So I'll conclude with this part. See here, I won't go into much of the mathematics, but as you all know, complex numbers have been there. Complex numbers means you're combining 2 real numbers, A and B, and with the imaginary number. Imaginary number is square root of -1. So common man will say this is foolishness. I cannot have a square root of -1. So that's what it was dismissed. Although this was introduced 2,000 years ago, time and again people started taking it up and again dismissing it, and up to 500 years back. So René Descartes was the first to give this imaginary number, and then Schrödinger make very good use of this imaginary number to establish quantum mechanics. Now, apart from this traditional use of the imaginary number, we also have what's known as dual number. So here it looks very strange. You are saying that epsilon squared is equal to 0, but epsilon not equal to 0. Can I have a number whose square is some value, but square root is not that? So it looks a bit mind-boggling. Go to the next one. We have what's known as a split complex number. Here again, we have a split complex number. J squared is equal to 1, but j not equal to plus or minus 1. Normally in mathematics, we are taught if j squared is equal to 1, then j is equal to plus or minus 1. But why are we defining like this? Because it has a physical significance. Sometimes we are multiplying 2 numbers or some phenomena, but the result is not matching with the product. So we introduced meta-complex. We are saying that there's a range of imaginary numbers. Just like I squared is equal to -1 is one imaginary number. I squared, j squared is equal to 1 is an imaginary number. J squared equal to 0 is an imaginary number. We kind of have a range from -1 to +1. Infinite imaginary numbers. So that is our proposal. Next. So how will it help us by coining this imaginary number? Because I am telling the context of achintya. Our Shastra says everything is inconceivable. How the Lord is manipulating this material world, what is the relationship between one living and this all achintya. So this achintya concept is there in material energy also because it belongs to the Lord. And this achintya portion is can be represented using this imagined number. So this is a graphical representation of how the complex numbers are used. Complex numbers use a graphical representation. You have can represent a circle, the dual split complex number like a just like you have 2 points, n number of points. You try to normally join it with a straight line, or you try to parabola, polynomial, different bits you are trying. But if it's a complex number, you can get a circle, and split complex number different, and particularly in meta complex number, you get a spiral graph. So you might have noticed that in the pineapple also, there's a spiral forming. Fibonacci sequence. These are all said to be golden numbers, which means the material nature has some beautiful synchrony. How do we explain that unless you have these kind of numbers? So I will not go into the mathematics, but basically what this is saying that law of conservation of information, that's what I said in my inaugural address, that we say mass is conserved, energy is conserved, moment is conserved, but we come across many times the reality is not that. Of course, in study, but if you go to the reality, it is not conserved. So then what is conserved? Information can neither be created nor destroyed. If you accept that, then like for example, a passage is there. I'm reading a passage in English, or Bhagavad Gita is there, I'm reading it in English. Another one reads the same book in Hindi. They are simultaneously one and different. Simultaneously one in the sense the context is the same, the message is the same, but different in the sense that the language is different, the text, the symbols I use are different. Next. So then we have, if you want to describe reality, either you say this is the one event is followed by another event, which means the second event will not happen unless the first event has happened. Supposing you are having a child means you should have had a relation with a man or woman. So which means the child cannot be produced unless something happened before. So which means these are dependent events. So can we represent that using this mathematics? And some events may be totally unrelated. So then next one. So that's represented by that independent events or parallel events. So any event you observe, either they are similar or they are one after another or they are happening simultaneously. So we need a mathematics to explain all these kind of phenomena. Next. Okay, next. Quickly go. So these are some mathematical identity. Just go back to one slide before. So this is the crux of my problem. We have x minus a, x minus b. This is the nonlinear equation. It's a quadratic equation. But let us say I convert this into the other form on the right hand side. So what's happening? I'm converting into the square of some linear relation. So if the left hand side is 0, then if the right hand side becomes linear, just I have to find out x is equal to a plus b I am. So it's easier to convert the nonlinear equation to a linear form if you use imaginary numbers. So that's the crux of my next. Okay, this is how to go from explain something in higher dimensions using lower. Yeah. So this is further mathematics. The dimension, how to explain something in a higher dimension using lower dimension, and vice versa. Okay, this is an application to Schrödinger equation. So basically, the problem is we talked about the entanglement. You have a measuring device and a measured object. Supposing you're measuring the temperature, you're using mercury. So mercury has some properties which depends on temperature, and the object which you are measuring, whose temperature you're measuring, that also responds to the temperature changes. So because these measuring device and the measured object have some common properties, you can say they are entangled. So if you have an equation for the measuring object and the measuring device, then you have what is known as an entanglement. Now the problem is, as I said in the beginning, this object has many properties. A machine cannot simultaneously detect all the properties of it, one by one only. But as a human being, I can conceive of an object simultaneously all the properties. Supposing you know some person, immediately you can recollect everything about that person. But as a computer is concerned, it can recover information only one at a time. So that is the challenge of quantum mechanics. So I have derived all this mathematics here. I am not going to all this. Next, quickly come to the next application. Next, please. These are some applications of this law that I proposed. We can use real and imaginary parts to represent relational properties. As I said, if a computer sees the audience here, you can at the most recognize that here is a man, here is a woman. But no machine can say that this man has this relation with this woman. So only a human can do that. So maybe if I use this imaginary number concept or achintya concept, then a machine can act intelligently like a human being. That's the quantum intelligence. So we use logic gates, AND gates, OR gates. So these also can be replaced by imaginary numbers. Next, please. Next, okay, these are some applications in artificial intelligence, big data analysis, quantum computing, game theory. The chess is there, chess game is there. We see come across that sometimes a computer defeating the chess champion, sometimes before that chess champion defeating the computer. But then it looks sometimes the machine is more powerful than the human being. But if you do a careful analysis, the machine can never supersede a human being. Ultimately, the machine is made by an intelligent human being. So it may apparently look like the machine is defeating the human, but human is always superior because we have this quantum nature. Okay, next. Okay, fine. Go further. Next, that's all. Thank you.